Let's define inverse trig functions. So we're going to talk about inverse trig functions. Inverse trig functions give angles as answers. There are two ways that people write inverse trig functions. If I want the inverse of tangent, then I could call it tan inverse, just like an algebra statement, of some value x, and that's going to give me an angle theta. Or I could call it arctan. Those are two things that mean the same, arctan and tan inverse. If I want arc cosine, if I say that, then that's some angle, let me call it an angle beta, and that's the same thing as the cosine inverse of x. So the notation is that you make this look like the functions to the -1. It means inverse function. The same thing as inverse function is arc. So those are some definitions. Now let's look at some things. If we've got the arc sine of x, I'm just going to say x, or if you want to call it sine inverse of x, then your answers, your angles, are going to be in quadrant 1 or quadrant 4. If you have arc cosine of x, the inverse of cosine, the answers are going to be in quadrant 1 or quadrant 2. Now I know that looks kind of strange. Angles in quadrant 1 are positive when you take the sine. In quadrant 4, if you take the sine, you get a negative answer. If you've got quadrant 1, the cosine's positive. Quadrant 2, the cosine is negative. If you take arc tangent of x, then that is tangent inverse of x, and the answers for those are in quadrant 1 or quadrant 4. So this is just a little bit of a scenario that you have got to kind of get used to. You might refer to an identity list or something like that for arcs. So let's start out doing a few examples. What if I'm given and say I need to answer my question in radians? So let's say y is in radians. So let's say I have y equals arc tan -1. Now what that means is that the tangent of y is equal to -1. If you perform the tangent function on this side and on this side, then you will get the tangent y here. You'll get the tangent of the arctangent of -1. Tangent and arctangent undo each other, so you will get -1. Now where's the tangent of y equal to -1? Well, the reference angle, and remember we are in radians, so the reference angle is pi over 4, but it's negative, so your answer's got to be in either quadrant 1 or quadrant 4. Tangent's negative in quadrant 4, so the answer to this is minus pi over 4. Try another one. Let's have y is equal to the cosine inverse of -1. Now again, that one's like this one, except I used inverse, and so that means the same thing as the cosine of y is equal to -1. So where's the cosine of y equal to -1? What's y? Well, we are in radians. The cosine is -1 at a reference angle of 0. And so if I'm going to do radians and get a -1 reference angle, I've got to be in quadrant 1 or quadrant 2. So I'm going to have y is equal to the 0 reference angle in quadrant 2, which is going to be pi. Another example, let's say that y is equal to the arc sine of minus the square root of 2 over 2. Well, again, this is the sine of y equals minus the square root of 2 over 2. So if I look at that, sine is equal to square root of 2 over 2 has a reference angle of pi over 4. Sine of pi over 4 is square root of 2 over 2, but I need a negative, so I'm going to put it in quadrant 4. There's where sine goes. So the answer to this one is minus pi over 4. Now let's do a couple with degrees, just to change it out a little bit. Let's say that theta is equal to the arc sine of the square root of 3 over 2. Well, if I look at that the other way, and you don't have to do this if you start recognizing it, but this one's going to say that the sine of theta is equal to the square root of 3 over 2. Where's the sine of theta equal to that? Well, the reference angle is 60 degrees. And sine of theta has to be in quadrant 1 or quadrant 4. This has to be positive. Sine is positive in quadrant 1, so the answer is 60 degrees. Let's look at another one. Let's say that theta is equal to the tangent inverse of the square root of 3. Well, if that's the case, then as we've been doing here, the tangent of theta is equal to the square root of 3. It's a positive, so I'm going to put it in quadrant 1, so it'll be the same as the reference angle. So here the reference angle is equal to 60 degrees also. So the answer to this one is actually 60 also. So there's a little bit of primary work that has to do with arcs or inverse functions. They are exactly the same thing.